triangle side ratios. We're back at it again, and instead of 45, 45, 90 triangles, we're going to focus on the next triangle that I mentioned in the previous video. So we're going to be looking at 30, 60, and 90 triangles. So, to refresh your brain, a 30, 60, 90 triangle, for if you ever forgot, and it's okay if you did, a 30, 60, 90 triangle describes the angles inside the triangle. So this would be, we would have a 60-degree angle, a 30-degree angle, and I hope this is obvious, a 90-degree angle. We know this is a valid triangle because if you remember, all three sides in any triangle, and this isn't just a right triangle, well, this is a right triangle, but it doesn't just apply to a right triangle. All three angles within any triangle, whether it's obtuse, right, scalene, doesn't matter what, not obtuse, I accidentally said obtuse, whether it's scalene, isosceles, or a right triangle, whether it's one of those three triangles, all three angles must add up to 180 degrees. And to prove that this is valid, which I hope there is no proofing, but if you are for some reason confused, I will prove this to you. So we know that we have a 30-degree angle plus the 60-degree angle, and this is equal to 90 degrees. Well, since we already have that 90-degree angle, we can take that 90 degrees, add the 90 degrees that we got up here, and this is indeed equal to 180. So this proves that this is a valid triangle. And, well, if anybody was confused, I hope that clears the air. Now let's focus on these side ratios. So, let's look at this triangle here. So we have a standard 30, 60, 90 triangle. So we know that this is going to be 30, this is going to be 60, and obviously that's 90. So if we look at this, let's say this side is x. Now if we look at this, this isn't like a 45, 45, 90, where this would be 2 times x, and this would be like 2x root 2 or anything. It wouldn't be that. It's a bit different. So actually, instead of this being 2 times the short leg, this hypotenuse would be 2 times the short leg. And this will all make sense soon. So we know that hypotenuse is going to be 2 times the short leg, which the short leg we defined as x. So the hypotenuse must be 2x. If we look over here, this is where things get a bit different. So this is equal to x root 3 instead of root 2. And I'm about to explain that in a second, and there's really only one way to help you guys understand this. So let's make ourselves a perfect triangle here. A perfect triangle. So let's say this is 2 centimeters in length. This is 2 centimeters in length. And this is 2 centimeters in length. So we have an equilateral triangle here. Now let's say you were to cut this triangle in half, right down the center. Let's extend that line a little bit. Now, you'll notice that we have a 90-degree angle here and a 90-degree angle here. Now, it's important to notice that before, I should have mentioned this earlier, that this angle from here to here, so let me do this in red, the angle between these two lines is going to be 60 degrees. Because it's an equilateral triangle, all three angles are equal as well as all three sides. So this from this line to this line and between these two lines here. So in fact, actually, I can redo this. I should probably mention this earlier. So we know that by an equilateral triangle, this must be 60 degrees. This must be 60 degrees. And this also must be 60 degrees. So if we, for chance, were to cut this little triangle in half, let's grab our line tool. If you were to take this triangle and cut it directly down the center, I'm not the best with lines, but if you cut it right down the center, we know that this is going to be 90, and we have 2 90-degree angles here. But here's the thing, since this is 60 degrees and we're doing a direct bisection of this angle, that means this is now going to be 30 degrees and this is now going to be 30 degrees. So therefore, like I proved over here earlier in the beginning, these are two valid triangles, even though we just cut a triangle in half. Right? So now we have 230. So instead of having a perfect little triangle here, an equilateral triangle, we now have two 30, 60, 90 triangles out of this equilateral triangle. Now, here's the thing. Based off of this entire side length from, I can actually erase this real quick, so I'm going to do it in red. But from here all the way over to here, we know this is 2 centimeters before we did the bisection of that piece there. Meaning that from here to here, this must be 1 centimeter. Because it's exactly half of it. It's a bisection. It's precisely half of it. So that means this is also going to be 1 centimeter as well. So now, let's just take this little triangle here. I'm going to outline it and I'll say blue. So let's take this triangle right here. I'm not a really good tracer here, but we're going to take this triangle right here that I just filled in with blue, and we're going to draw it over here again. So, let's make it blue, I guess. How about that? So, we're going to do, actually here, I'm going to make it a bit more, actually, yeah, I'm going to make it a bit more realistic here. Let's make it a bit more realistic. Alright, there we go. So, here we go. We previously determined that from here, this point, let's do it in black actually. We determined that from this point to this point is 1 centimeter. Because in the previous, before we did the bisection, it was 2 centimeters for two of these triangles put together. And we determined that this is 1 centimeter because it's a bisection, so it's precisely half of it. So we know this is 1 centimeter, right? Well, according to this must be 2 centimeters. This side right here, the hypotenuse must be 2 centimeters according to the ratio here, which is true because this is 2 centimeters in our equilateral triangle, leaving us with x here unsolved. We don't know what that is. So here's where the Pythagorean theorem comes in again. Remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. Now, we know that one side is a, and the hypotenuse, which is c in this case, is 2. So we can say 2 squared is equal to 1 squared plus x squared. But we can actually rewrite the equation as 2 squared minus 1 squared is equal to x squared. But if you get the square root of this, you actually say the square root of 2 squared minus 1 squared is equal to x, which in this term, x is this missing side. So if we expand this, 2 squared is 4, 1 squared is 1, so the square root, x, and we know that 4 minus 1 is 3, so the square root of 3 is equal to, not the square root, it's equal to x. And this is the square root of 3, because, well, you could say 1 root 3, because this is 1, and it's, according to this law, it's whatever x is times root 3, but 1 times root 3 is already root 3. So this, by default, is root 3.